Hello. So in today's video, we have a question two buttons from Codeforces and we're gonna solve it today. The question saying that we have a machine. So we have a machine with a red button, with a blue button, and a panel showing some number. Okay. When we click on the red button, what we get is so we have two options. When we click on the red button, our number gets multiplied by 2. When we click on the blue button, our number gets subtracted by 1. So our logic is what is question asking? We have given an integer n. We have to convert it to integer n. How we will do is we will do is by clicking on a red or a blue button. Like we have to return the minimum number of times we click those buttons. So it is the question. If we look at the test cases, we have 4 and 6. Like we have to convert 4 to 6. How we will do is we will just like in minimum clicks, we have the answer as 2. So how is 2 coming? So here is it written that we will push the blue button once, then the 4 becomes 3, and then we will push the red button, then the 3 becomes 6, and these are the minimum clicks if we can convert 4 to 6. So how we gonna think this? Okay, so like we know that like if we think reverse of this question, okay, then we come to an approach that if we are going from n to m, then we have red button which will convert n into 2 and the blue button convert n into like n minus 1. But when we think it reverse approach, if we are going from m to n, then if we click the red button, our m will reduce to half or divided by 2, or we just say division by 2, and our blue button will increase it to 1, and we will reach to n. Like the question is like just telling us that we have to do m equals to n. Okay, m should be equals to n. Like if we reach to like equals state, then we just return the number of clicks we are doing. So how we will implement this? So it is our code. So now our red button will behave as opposite of the like previous when we were going from n to m, then our n will increase to the like twice, and now we will divide it to like half because we are just moving from m to n. So we are just dividing n by 2. So this will make our n reduce to half, and uh, like in previous one, we were like going from subtracting the n to 1. Now, if we are going reversibly, then we will just increase it to 1. How we will implement this into our, like how we will approach it? The approach will be so easy. Like we will just take inputs and we will take a helper, or we can say a variable steps to count the number of steps we are going. We will just iterate through a while loop. Okay, there is a base case in this question. The base case is if we have our m greater than n, then if we have our m greater than our n, then we will just think about an logic. But if we have n greater than m, we just have to reduce it. Like if we think reversibly, then if our m is less than n, then we will just return n minus m because we have no option to reduce it. Like, and we can't reduce m if we are going from m to n. Then we will just decrease it. Okay, we will just decrease it. And for decreasing, we will just add n minus m to the steps variable. Then we got our answer as n minus m steps. If it is not like in the case where m is greater than n, what we will do is like if our m is even, then we will just reduce it to half. Else, if our m is odd, we will just increase it to 1 and till the loop will iterate, we will just increase our step to 1 and return the number of steps. Like this is the, you can say, optimized approach. Why I'm showing you the optimized approach first? Because it is the like the way of thinking. Now, as the question was asking about the DFS approach, how we will approach the DFS? As it is written that it is the question from DFS and graph. So now we will look at the DFS approach, how we will go to the DFS approach. In DFS approach, we will also think to like the reverse approach. We will go from M to N. We will make M equals to N. We are not touching the N because uh, if we go like to N, then like it can increase our search space or make our result like it can go so much big value then like it is not optimized one. And so we have chosen M, so we can reduce it to like half and increase it to 1 by clicking red and blue buttons. So how we will gonna do is like we had already talked about the base case. If we have our M less than N, then we have no option. We have no option. We just have to increase it. Okay. We have no option. We just have to increase it. We just have to click the blue button. Okay. So if we have our, you can say, if we have our A is like denoting the M, B, like A is denoting the N, B is denoting the M. If we have M less than or equals to A, we will just return A minus B. It means we just have to click the blue buttons N minus M times if we have N greater than M. Okay. And like this is the base case of our problem. But if it is not, okay, if we have M as greater than N, then what we will gonna do is if the M is even, then we will just do it. We will increase our, you can say, like it is the recursive approach because it is a DFS approach as like we are going like to the statement of question only. It is the DFS approach and DFS is a recursion approach. And in recursion, we like we can do is we just add one every time so that we will get the result as at the last in the like the last step of recursion we will get our the minimum steps. Okay, so if it is even, if m is even, then we are just doing is decreasing it to half, and if it is not even or we can say it is odd, we will just increasing it to the 1. Then we will get our result as a like this only. Like we can go like from n to m, and to optimize it we can memoize it. Like we can use a map, an ordered map, and we will just memoize it. uh, how we will go through that approach. So this is our memoization approach where we are going from n to m. We are going forward only. So as our base case we are just returning a minus b, which is n minus n if n is greater than n. If a is less than 0 or equals to 0, we will just return b, because from 0 we just have to we just have to make the m decrease to the m times, then we will reach to the, you can say, 0, because less than 0, our like machine gets break down, or we can say our machine stops working below 0. So we are just returning the b at that case. It is the base case. Now, like if we like what we are doing is we will just go to the option one is increasing it to the double, and option two is we are just subtracting n to 1, and these are the both recursive ones, and we are storing those results in option one and option two, and we will just get a map the minimum of option 1 and option 2. Then we are just storing in the map, and if we find the result, then we will just return the map, which is a big of one operation, and it is the memoization approach we can think of, but it can go out of the bounds and cause runtime error because the search space become so much big and large. So it is not the optimized approach. So we have to think about the reverse approach only, where we are going from m to n, where we are reducing m to half and adding 1 when we click the blue button. So thank you for today.